Hello everyone, I'm Jerron Crawford and this is Electronics Physics Class 206. Today I'm going to be taking you through the analog display. Excuse me. Alright, so what we have here is 7 multiplexers. What they do, they're pretty much processors. And what we have here is our counter. Multiplexers are 150s and our count is the 7490. These are TTL compatible. What the counter does is divide by 10. So what it will do, it will cycle through the inputs from the multiplexers, and the multiplexers are going to send their signal to this here display. This display is an analog display, which is different from this one. This right here, this one is digital. What this one does the same thing, but it already has the inputs already in place, and the chip is already in place to where you can just hook it up and it'll cycle through your numbers 1 through 9. With this display here, each one of the little segments of light, you have 7 segments. Each of those are controlled individually by one of these here multiplexers. So what we had to do to set up, the basic setup is a lot of wires, I know, but what we had to do is from 0 to 8, we had to determine whether the light was low or high. So for instance, this first multiplexer I have run into the top segment of the light, right there. And for each number, you have to determine whether you want the light on or off. And that'll be determined by whether you put a low input or a high input. A high input, obviously the light will be on at 5 volts. A low input, the light will not be on. So here, just say for instance for the number 1, excuse me, for the number 0, we wanted that top one to be on. So we put it to a high input. We have a 5 volts running here and in a column, so all these down the column are at 5 volts. And then say for instance for the next number 1, this top light here, that top light there, we would not want that to be on for number 1, since our 1 only takes the 2 left lights to display. So we had the top one at 0, or excuse me, low. So the light wouldn't show on or come on at that time. All right, so we had to do that individually for each one of these individual little segments here. So that's why we have 7 chips for each one of the segments of the light. After we connected all of them to high or low inputs, then we had to connect our counter. Like I said, from this counter has 4 inputs. Excuse me, this counter has 4 inputs or 4 outputs, so it will cycle through 4 numbers. So what we did, we connected the counter to each one of these, so they'd be to each one of the multiplexers, so they would be synchronized, so that the analog display would show the numbers correctly. And like I said, we did high through low from 0 to 9. All right, one thing we had to be sure of, originally when I set up the circuit, it was shorting out, and that was because I had a low input connected to ground and to a high input. You want to make sure you go and recheck all your circuitry. Make sure you check all your inputs to keep mistakes as minimal as possible. All right, we'll turn it on, and as we can see, it is cycling through. One difficulty was that this bottom display, it works when you set it up to 5 volts, but for some reason this chip placement was bad. And I tried replacing the chip, but for some reason I still could not get it to work. Other than that, it went pretty smoothly. There were a lot of wires. It took me about 3 to 4 hours to complete the circuit. So I would give it about 80% efficiency rating. Hopefully next time we'll be able to get it to cycle through completely 100% correctly. But this is analog display, and there we have our number cycling through. Also, really quickly, we just had it at a basic low frequency, about maybe 5 to 10 hertz or so, nothing too fast, is the TTL, and with a square sine wave to make sure our input was correct. Other than that, that's about it. It was a lot of work, a little tedious, but all in all, it went okay. Thank you.